All right, last session of the day. Thanks for showing up, folks. This is Adventures in AI, deploying and inferencing open source and custom models on Kubernetes, if you don't know what that acronym stands for. My name is Josh Palm. I'm the principal PM for Azure Kubernetes Service. This is not Sachi.
I am not Sachi.
Sachi was meant to be my co-speaker today. She works on essentially everything that is related to how AKS can be a platform for AI workloads, but unfortunately she couldn't make it today. So I asked Paul, because we actually have a history of talking about AI and Kubernetes that started, I think, in Build 2023, where we started to discuss a few things on how you could, at the time, connect AI services to applications running on Kubernetes and how we're making that easier and simpler. And this is kind of us at Build 2023.
Wait a minute. George, are you the new Scott Goo or something? This is like the red jacket thing?
Should get new clothes.
Wait, I think I'm wearing the same jacket too.
Yes, you just got darker. Yes.
Okay.
So I think probably also at the time we were the last session before drinks.
We were. It was the last session of the day.
It's becoming a pattern. Us doing that. So between then and now, what has changed? And I think it's an understatement to say a lot. Over the last 2 years of change in regards to AI. You've seen it across the keynotes from Satya, from Scott, Mustafa, across Build and Ignite and many more. And the growth of AI services, solutions, catalogs, use cases, scenarios has been completely night and day across Azure. The ease of using AI for everyone, be it a technical professional or not, is just completely unparalleled from before. But there's also something that we've started to learn and to see from before. Whereas in 2023, most of our demos and most of our content was around connecting to existing API endpoints that existed, a lot of them proprietary endpoints, developed by pioneers in the space like OpenAI. That has actually changed a lot. And we've seen, like it usually happens with most technologies, with most stacks, open source come in hard and working on democratizing that technology a lot. We've seen the likes of Mistral and DeepSeek and Hugging Face, across the board, enabling as usual and creating a transformative moment where we are right now for software and AI, where no longer you're having these cutting edge models locked behind proprietary APIs, maybe gated by costs or tokens, where you need to figure that out. It's actually, once again, as it's usual with open source, giving us, and hopefully you, developers, the freedom to build with intelligence on your own teams and on your own terms. Now, as you start to look at things like model inferencing, and if for a lot of you that's still like, I've heard that mentioned many, many times and I actually don't know what that stands for. Inferencing is essentially the process of serving trained models in real time. So that model's already trained and now you're serving it and ideally consuming it with an application. Now this is a pretty compute intensive, latency sensitive with latency and highly dynamic type of workload. And with a lot of you, like the developers in the room, not a new scenario, not a new requirement that you've seen. You've seen these exact same requirements across your applications. I'm sure you had to work on applications that were kind of pretty latency sensitive, that you need to have granular control over, that scale pretty rapidly, that you need to maintain with very, very careful uptime, that are very dynamic. So it's actually very similar to a lot of the challenges with applications that we've been seeing in the past if you're leveraging open source models across your infrastructure. So what are some of the typical challenges that brings you in? And usually it's, well, if I'm running models, one of the key differences from just running any application is that usually you need specialized hardware. You need GPUs, putting it simply. You need to quickly scale those up and down. Find them, if you can these days, and then scale them up and down. You need to be able to use them in your platform. Have the right drivers, have the right endpoints to then make them available to be it models, agents, applications, and more. Sometimes you need fine control, like fine-grained control over how to customize the drivers, how to specify the right versions, how to ensure compatibility with your applications. And you need to, now that open source has entered the room very heavily, you have a plethora of solutions out there in the, essentially the cloud native space. And you've seen from Scott yesterday morning, that Microsoft is now, maybe to the surprise of many people still, the #1 contributor to the cloud native compute open source projects, where a lot of these things are coming through from, and a lot of this innovation and leadership is coming through. So the equation became pretty apparent across the years, which is now that open source is coming to democratize this usage of AI, to use AI on your own terms, in your own way, as you need it, you'll typically want to run it at scale for your applications and for the model's sake. That means something that hopefully for some of you that are joining us here is pretty familiar. That's exactly what Kubernetes as a platform was created to do, to run applications at scale, dynamically, to abstract a lot of the underlying infrastructure challenges that you might have. And you've seen a lot of this before, I'm sure. And the same thing is true for applications as it is for AI models. Kubernetes is great because it allows you to have this dynamic scaling. It abstracts this more complex infrastructure side of the house all the way down to the host and the servers. It allows you to have portability because it's a standard now across clouds and environments. It allows you to have staged deployments and control, so you can, with models, that just means new versions of the model. It might mean trained and fine-tuned versions of the model that you can easily do. It allows for collaborative development. Pretty great for all these things.
The one thing also is that Kubernetes is like super extensible, right?
Yes.
You can build on top of the Kubernetes APIs and build whatever you need and have it all orchestrated for you. So I'm a little biased with Kubernetes, like, to be honest, so sorry.
And where do we come in, right? What's Azure's role in all of this? What's AKS's role as Azure Kubernetes Service in all of this? First of all, show of hands, if any of you are already a Azure Kubernetes Service user? I love you all. For those of you that are not, we like you as well. We hope that by the end of this, you might become an Azure Kubernetes Service user as well and see how it can help you and be your platform of choice as well. It is the platform of choice that we see from a lot of the pioneers in this space already for many years, all the way since 2 years ago and beyond to today. We have partners like Mistral or OpenAI, users like Wave, pioneers in all their respective spaces, from models to autonomous driving vehicles, and all of them, running their innovation in Kubernetes and in AKS. Why did they choose AKS specifically for some of these workloads? Well, let's look back at some of the challenges, right? And I mentioned these 4 critically. Specialized hardware access, quickly scale that same hardware without, having to fiddle with infrastructure, having the right defaults and controls, and then the ability to integrate with common frameworks and libraries. Well, in Azure, and you've heard a lot about this hopefully at this point, the plethora of GPUs out there, A100s, H100s, H200s. You might have heard from Jensen from NVIDIA about the GP200s, GP300s, all of those made available to you in AKS as they become available in the market. And more than that, abstracting away a lot of the complexity to provision them, to install the right drivers, to configure, and all the things that cloud simplifies for you from an infrastructure perspective. But it's not just that. It's then the next step, which is scaling. It is the steps of ensuring that you can, with a common standard, maybe a node pool standard, have the same GPUs, mix different types of GPUs, test with different types of GPUs, and leverage things like Kata, which is a Kubernetes event-driven autoscaler, to scale your GPUs and to scale your workloads based on GPU usage. If you look at that second link, which was made live today, you'll find out how you can actually use Kata and the data center GPU manager from NVIDIA to scale your workloads based on the actual GPU usage given from the GPU itself, the underlying GPU. You're able to export those metrics to Prometheus and then use Kata to scale based on the Prometheus usage that is being monitored from the actual GPU. So you no longer have to say, oh, I have 1 GPU, 2, 3, 4, and then I'm just basically allocating and scheduling, and then scaling means just getting more GPU and allocating something to it. You can actually scale based on the usage of it. And particularly interesting when you're looking at things like so-called MIGs, which is the multi-instance GPUs, where you can actually partition and use the partitions of the same GPU across multiple applications. Seems pretty wild, but it's actually being used in CPUs for ages at this point, which is the ability for multiple processors to share the same CPU. But this is possible now with GPUs as well. And each portion, in this case the A100, for example, gets all up to 7 partitions, which you can configure. And then you can just assign them like resources, like in your deployments and in your pods, the same way like that. Doesn't take you any more complications than that. Kubernetes and AKS abstracts the rest for you. And you not only get that partition of the GPU, but you also get a partition of bandwidth, of memory, and cache for those workloads to use. So it allows you to be much more efficient and to be much more cost efficient, of course, but also just resource efficient in the usage. The other thing is, as you saw some of those logos, and you look at maybe some of your use cases, we see that 90%, and I'm probably being generous, maybe 99% of our users, they just leverage our defaults as is. They expect to spin up a GPU node pool and to start running workloads that leverage GPUs, whether they're gaming or whether they're AI agents, doesn't matter. They just wanted them to work out of the box, and that's what we want for them as well. In other cases, as you saw from the 3 examples that we showed on screen, these are pioneers in their space. They have really, really, really niche and particular needs, and so they need flexible controls in their case. So whereas some users will want the very smart and best defaults possible and just work out of the box, others might need flexible controls that allows them to do things like specify the CUDA versions, map things to the specific kernel versions, to do things like time slicing, which is the other way that is not about MIG, which is infrastructure-based, where you're sharing an actual GPU. In this case, you're sharing time with that GPU. So this workload can have some time with it, and then this workload comes in and has some time with it as well. And they can still be running, but they're time sharing that GPU.
Like time sharing? Like
yeah. But in a good way.
Okay.
So if I can change the slide, there you go. We're pretty happy to announce that in order to achieve this balance between smart defaults and granular control, we're GAing today the custom GPU driver installation. This allows you to continue exactly as you are today, creating node pools and leveraging GPU nodes out of the box, or decide to bring your own GPU driver installation. And you can leverage things like the NVIDIA or the AMD drivers and operators that you can then customize to deploy your own versions. You can bring network operators as well. And yes, we have solutions for all of that. So that's why I said 99% of the cases, we expect you to just leverage the things that are there out of the box. But if you have any customization needs that go beyond what those features already provide, you can leverage your own GPU driver installation. We'll just give you the GPU, bootstrap it, make it a Kubernetes node, and then you can install all the drivers yourself and customize it. Finally, we want to make sure that you have the breadth of the ecosystem at your display. From folks like Ray, folks like Anyscale, you're able to leverage all solutions out there, open source and 3P vendors, a lot of our ISVs and partners, all run on Kubernetes natively. But as we look back, since those 2 years that we presented that, there was clear there was a key gap. And we heard the question many times, actually, throughout this week, especially because it was in the top title of our booth, which was, can I run agents on Kubernetes, and what does that mean, and how do I do that? And I was pointing people at this session all week, mostly. And so ever since then, we announced something that you might have seen, which is the Kubernetes AI Toolchain Operator, or Kaito, which allows to automate the deployment and management of inferencing and tuning workloads in Kubernetes. What that means is you can pick up any model from our catalog in Kaito, like Llama, et cetera, the same way that you do with things like AI Foundry and a lot of the Copilot Studios and more, and deploy them to your Kubernetes cluster and run them there locally in a self-hosted manner. But not left to your own devices. We manage that for you. So we manage that life cycle. We take the guesswork all out from your hands. We provision the GPUs that are needed. We configure, we tune them. And then you can just focus on using the model in your application and tuning the model if you want with your data, as Satya mentioned on Keynote in day one.
Yep.
You've been using Kaito for, I would say, a little bit.
Yeah, a little bit. I do a little bit with Kaito, yeah.
Why don't you tell us a bit about what it's great about Kaito and how folks can use it?
I mean, the one thing that I think is like super cool about Kaito is that it basically addresses all of the 4 concerns that George just talked about. I mean, specialized hardware, being able to auto-provision, being able to use familiar frameworks and libraries, and then also having smart defaults, but being able to also further customize if you wanted to, right? And so using Kaito for your inferencing workload based on open source models, I think just makes sense in Kubernetes, right? Kaito is basically a Kubernetes operator that basically is entailed of 2 different controller components, okay? And I'll talk to you a little bit about how that works, okay? So basically what happens is Kaito is an acronym for Kubernetes AI Toolchain Operator, and with an operator, basically you're gonna have 2 controllers inside of Kubernetes. Remember how I said Kubernetes is super extensible, you can build upon the APIs? Well, that's exactly what the Kaito engineering team has done. They basically provide 2 controllers that are in the Kubernetes cluster. One is the workspace, the other is a GPU or the node provisioner, okay? You, as the user, you don't work with those specifically. You only work with, for inferencing, 1 custom resource. And so as a Kaito user, all you do is you submit a YAML manifest into the cluster, and once that manifest is in the cluster, the workspace controller will basically reconcile that. It's gonna see what sort of specifications you're asking for, the GPU node you want, the actual open source model that you want, and it'll act upon that. The workspace controller will then submit its own custom resource on your behalf for you and ask for a node claim. Because you see, Carpenter is actually built on top, Kaito is built on top of the Carpenter APIs, and a machine config or a node claim is actually submitted into the cluster, which then is reconciled by the GPU provisioner. The GPU provisioner, now at this point, we're just talking normal Kubernetes resources. So at this point, a GPU node is gonna come up, which is, scaled up. The thing that you said is pretty important when we're talking about running your own model in your own infrastructure. So the GPU node comes up, and the workspace is basically constantly listening, waiting for the node to be ready. As soon as the node is ready, the deployment goes out. Naturally, replica sets and pods go along with it. The pod will download the model, and as soon as that model is ready to be used, the vLLM runtime will then fire up, and now you automatically have an inferencing endpoint using, right? It supports open AIs, APIs, and SDKs. So whatever ML or inferencing endpoint you were targeting using applications that use the OpenAI SDK, you can actually use that and continue to use Kaito as your backend model, which is super cool.
So you're saying that the application we did and we demoed 2 years ago,
yeah,
that was using OpenAI API,
yeah,
I could just replace that in place with a Kaito model.
You
model
could.
running Kaito. Right?
Yes, yeah, you could. As long as your application is already using OpenAI's API, yes, it should be a drop-in replacement, and we'll see something like that in the future, okay? So that's basically how Kaito works.
That seems a bit complicated on that, how it works though.
Yeah.
Is the functionality hard? Like if as a user, I might not care about all that.
Okay, fine. I glossed over the whole installation part, okay? So right now, the manual installation, we're talking open source, right? So you can literally do a Helm install, the 2 controller components. But what if you don't want to do the Helm install, right? What if you want to empower some of your developers just to go do this on their own? Well, this is where we can actually lean on the Visual Studio Code extension for Kaito to actually install it as an add-on to your AKS cluster. Add-on meaning the AKS team will just manage all the components for you, do the installation, and take care of all the updates for you along the way. And so this is what this demo here is going to do. It's going to show you how you can just work within VS Code, make sure you install the AKS extension, which will install the Kubernetes extension as well. And then from that point, what you can do is you can basically log into your Azure account, right-click your cluster, and install Kaito. We're talking right-click deploy at this point. This video has been sped up because it does take a few minutes to install, but as soon as it's installed in your cluster, you can literally generate a brand new workspace, and we will get to that in a second. So there's a whole bunch of stuff going on behind the scenes here. We're installing the add-on, doing the managed identity, doing the federated credentials. So there's a lot that goes on behind the scenes. As soon as the add-on is ready, you can actually browse the model catalog and see all the open source models that are available right now as a preset. And you can just click deploy, but you can also further customize, right? We're talking about smart defaults and ability to customize, and we can do that. Or we could just, right here, we just deployed the default workspace. And this whole time, you're just waiting for the resource to come up, right? Like how I explained. And then as soon as that's up, the workspace and the VLLM server will come online. And you can immediately start testing your endpoint, because it's just the REST API endpoint at this point. And you can just manage your entire workspace all within Visual Studio Code. You don't have to do anything outside of that. Okay, so here we have simple prompt engineering, right? Because that's a big component of building your AI application. And you can start tweaking the bars here, and you can ask it a question. What is Kubernetes?
Never seen that before.
It's like in all of our samples, what is Kubernetes? So it comes back with an answer, right? So this is great. We stood up Kaito in our AKS cluster as a managed add-on. We're able to query the endpoint. What else can I do? I mean,
Well, you mentioned a couple things there. First of all, what's a VLLM server?
VLLM server is a super popular open source inference runtime server, okay?
So that's what we use in Kaito.
That is what we use. It is the default, but remember, you can split off and do your own thing. You can use Hugging Face transformers as well, but it just naturally defaults to VLLM.
So all of this, if I just did next, I get VLLM.
Yep.
And I can just deploy, in this case it was 5.3, I think, and just start using it.
Yes.
But what does start using mean? Because I'm pretty tired of these test demos where we just ask, what is Kubernetes?
Yeah.
How can I actually use this in my app? How can I use this in an agent?
Yeah.
Which is a question we got all week.
Right. So let me show you one more thing. I mean, it's just, this should be a rather quick demo. Basically, the whole point here is just using your existing OpenAI packages, and you can query this endpoint, and then I will get to that request.
You promised that we're going to be running an agent.
I promise.
Okay.
I promise. Yes. So basically, we're just calling we're just downloading a simple Chainlit application, just using the same OpenAI libraries. And then what we're going to do is we're going to be able to just port forward the Kubernetes service. Remember the VLLM service that's behind the scenes, and then we can start interacting, and we can play with the model further outside of the VS Code extension. So I mean, it's just simple as that. It's all an endpoint. Okay.
In this case, that's how we connected, in this case, this actual application into the model, and now it's serving as a direct chat.
Correct.
With the model running on Kubernetes.
Yep.
Serving. Okay.
Yep, that is correct. Okay. And so what that highlighted is some of the cool stuff that the Kaito engineering team has been working on, right? VS Code extension, which is super awesome, and defaulting to the VLLM inferencing runtime, right? Not only for the SDK compatibility, but also for monitoring. So remember that. Now,
the other part I think that it's interesting is this where it ends, right? We have a model, we easily started, we downloaded it, we tested it, played with it, now connected an app to it. Are we done? And this is typically no. The actual loop that we typically see from users all the way since the last 2 years is a little bit more complex today. Hopefully not too complex, but a little bit more complex. Well, it all starts, hopefully, with a lot of the inspiration that you're gathering this week. And are you actually getting cool business cases and use cases from this week? You have a lot of them in your business. Are you able to quickly get started? Like, for example, what we just did in VS Code. Install Kaito, select model, and deploy to my existing or newly created AKS cluster. Touched nothing else than that. There was nothing special beyond that demo. There was an existing Kubernetes cluster, and everything that Paul did was exactly what you saw.
It's what we were doing back in 2023, right?
That's exactly. But then what's next? So you can experiment with more foundational models. You can see which one is best for you. Was that one the best model maybe for the chatbot? Was that it? Is that the best model that we can do for document generation for our law firm? You can experiment with that quite a lot. And you can then start developing your application that Paul just briefly mentioned across the board there of just like connecting the model, using the OpenAI APIs, importing that, very popular, very well-known and well-documented now, and just continue from that with any of these models. And again, I need to say this again, any of those models, you can use those same APIs and you can then replace, in place, any of those models and start to consume them from your API. But what about something that Satya talked about in the keynote on Monday, which was around providing it with your own data, with your own context, your own grounding. And that's really, really important. And it's really what's next for us. So the one thing that Kaito also aims to do is not just inferencing, but also tuning. So what can you tell us about tuning? What's about this new jobs thing that just showed up in this diagram? You showed us before.
Yeah, so jobs is it's for you Kubernetes users out there, jobs is not a new resource, right? A job is something that needs to be done. It's a job, right? And so Kaito also supports the ability to fine-tune your open source models. Basically, you give it an input data set in a Parquet format, you fire up a workspace, right? The same workspace that I talked about. And then you basically tell Kaito to fine-tune that based on the input data set. And then the output would be an output adapter that you could then slap on top of your inference workspace so that now your model is grounded in your data and it can start to answer questions that are more relevant to your organization and give you answers that are more relevant to your users. So
you typically have like your base model.
Yeah.
And then you add your data for additional context and you get more accurate answers. Pretty much the same thing that you saw on the keynote demos on Monday.
Yeah.
You can do it in your own infra in AKS and in Kubernetes equally easily.
Yes. That's correct. And very similar to the demos that we saw on Monday, where I think Satya was doing the PR review.
Yes, right.
And he did a / command, or no, he added the GitHub Copilot agent into the PR.
We saw that and we say, I will not be upstaged.
Yeah.
And we decided to change all our slides and demos.
That's right. So the demo that we have here, right, Kubernetes, right, we're naturally gravitating more towards the open source. And so the demo here is basically demoing a open source project called PR Agent, which is made available by the organization Codium. They used to be Codium.
Codo.
They're Codo now, yes. So this open source project is basically a PR review agent that can take a look at your PR. But the key thing here is we could use Kaito as the back end.
So your model is running locally in your Kubernetes cluster locally.
Yep.
And then you're basically doing the same as GitHub Copilot here, though, right?
Yeah.
Why wouldn't I just use GitHub Copilot for this?
Well, I mean, there could be a number of different reasons, and it's really based on your organizational needs. I mean, you guys might have data sovereignty things that you need to be worried about, data compliance, data security. So, I mean, the reasoning could be a slew of things.
Right, we have a lot of users that come to us and it's like, I love every demo you're showing, but I can't actually use Copilot, or my organization is not allowed, or I can't put Copilot, give the context of my repos to it and do all of those things. And now I'm sad because I can't benefit from any of the things that you're showing that are cool in these keynotes. Yes, you can.
Yes.
All right.
So in this demo, what we're going to do is we're going to use Kaito. We're going to configure the PR agent in our Kubernetes cluster, and then we are going to fine-tune that because the answers that we get back from the initial PR review
might be good, but might be bad.
I mean, it could always be better, right?
I need some code standards from our organization. I mean, in AKS, we have a number of code standards that we have specifically for Go, which is where we build both Kubernetes and AKS in Go. And so we loaded a lot of those standards into our own PR reviews, and we did the same thing here as well.
Yeah, so here is a Kaito sample PR reviewer application that's available on GitHub today. Some of the engineering folks on the AKS team actually put this together so that you can actually install the PR agent into your cluster. And so if we just kind of look through this real quick, this is, again, a Kaito-powered PR reviewer. So we'll just kind of take a look at the configuration real quick. So it's doing your standard service and deployment. But the one thing that we really want to focus in on is the configuration of the PR agent, okay? So we do need to add a few things into this to make it work for not only our GitHub, but also our cluster and model and the Kaito model in general. And so what we'll do is we'll actually deploy a workspace, and we've done this in the past with the VS Code extension, but this time we're gonna use a different model, a model that's more geared towards doing code reviews, which is the Qwen 2.5 Coder model. So we'll go ahead and install that and then wait for it to be ready. And remember, we're getting an inferencing endpoint that we're just calling again, right?
There we go. What is Kubernetes?
There it is again. That's right. So what we'll do now is we have the Kaito workspace, we have the endpoint, we just need to configure a GitHub application that will be able to act upon our PR request when we ask it to, query the Kaito model that's inside of the cluster, and then provide a helpful comment, review, and leave that in our GitHub issue. And so these steps are necessary to configure the application. Obviously, you want to configure this to be
giving permissions to issues, to the PR itself, to get comments, and all the things. So
and scope it down to only the things that it needs.
Exactly.
Okay? So we configure the GitHub application, and then we will actually call back to the Kaito and then further configure the PR agent deployment.
Right. So we go back into the configuration, which is completely removed from, not removed, but copied from the Kodo repo. But in here, we inject it into a secret because we're in Kubernetes. And then we're just going to add our model right here, which is that workspace endpoint. We're going to put our GitHub private key. We're going to put the app ID. And now we're able to call back.
And that's it. Yep. So now we've just configured the PR agent completely. And we are now able to use this endpoint. Okay. So we take that endpoint, which is the PR reviewer. And so basically, anytime we do a slash command, which we'll see in just a second, we'll do a slash command on the PR. It'll invoke the GitHub app, and then the app will then call the Kaito
agent endpoint.
That's running inside.
So every time there's a new PR, like in this case, we're basically doing, I guess, a Kubernetes controller somewhere there. And this is actual code. That is actual controller code that has been put there, some of it bad.
It will find it.
And we're now calling back into the agent running our Kubernetes cluster, calling the model that we're using in Kaito, and giving suggestions.
That's correct.
So as you said, we just do a slash review. And now this is using the authorization that we had, calling back there, and then getting all those answers, all those suggestions into it. So apparently we have some interesting ones.
Yeah. So it found an issue with our code and offered a suggestion. But remember, sometimes these suggestions are not grounded in the context of your organizational data. And so we can take this a step further and fine-tune the actual model with some additional data so that it could be a little bit more intelligent in the way it reviews our PRs. And so what we did here is we took a data set in Parquet file, slapped it into a container image, and then we're now going to put it into the Azure Container Registry. From there, we're going to do the tuning job, and we're going to basically send the container image as the input to the fine-tuning job, and then eventually the output will be an output adapter that we can then use, remember, to put on top of our original inference workspace.
They're using the base model, now throwing all that data set, running tuning. This is a tuning workspace, and then we're going to run inferencing again on the output of that.
Right. So once that tuning job is done, and it does take a little while, we can actually then look at the inference workspace and then slap on that adapter, and now we have a new working endpoint that has a little bit more intelligence in terms of how it's going to review. So we'll just update the endpoint in the PR agent configuration, and then we will just redeploy the deployment, and now we have a smarter model.
So if we just do the PR again, we expect to have a difference from before. So on the left, we have the previous PR and suggestions. On the right, we have the new suggestions.
That's
so as
correct.
expected, this is tuning, so the differences are not going to be massive. they're going to be a small addition
Yes.
to the concepts that it had before.
Right.
In this case, just a key difference there, maybe on how to even write the error back to us,
Right.
how to comment on those PRs, anything to look more from a standards quality
Right.
perspective.
Right.
Very, very good.
Right. So, I mean, tuning is one thing. Like, you don't just tune it one time and you're done. No, you eventually have to put some sort of like continuous automation in place. And so what Kaito can do is it can actually help you jumpstart that. And so you can start to build these elaborate event-driven workflows to kind of
Right.
like, you know, do that feedback loop as you were mentioning.
Very, very good. So that's the continuous tuning that we can do, basically doing this over and over again. And we could have multiple adapters.
Yes.
So we had
Multiple.
And you showed the original one, adapter one, and you could have 2, 3, 4. You could go bounce around,
That's
test your
correct.
app with one, test your app with the other, see the results, as easy as just changing that configuration as you do.
Correct.
Very cool. But I also said that this is interesting across a few different scenarios. So we did a little calculation, which is back of napkin calculation. Keep that in mind. But if you're using today a similar approach, 50 to 100 developers, and you're using a SaaS to do this, your cost will typically be around $50,000 per year. If you're leveraging Kaito, the same way that we just did here, again, the same number of developers, if you use a very high-end GPU like the NC24, again, the times that Paul was mentioning, that will depend then on the type of GPU that you use, of course. That could cost $21,000. Or if you use a lower end, you'll take maybe a little more time to get those inputs from a PR review, still typically faster than a human. I mean, for some reason on AKS, we have channels saying like begging for PR reviews. So I think it would be faster here in this case. And that would go down to $5,000 a year for an organization of 50 to 100 developers. That's a pretty good productivity case, and that leads to an average of 50% savings on cost for all of you. Okay, cool. So we announced Kaito a while back.
Yeah.
What is the announcement here?
You tell me.
So very, very happy to announce that from this week onwards, the Kubernetes AI toolchain operator is going to GA. The next release of AKS will contain all the GA bits for Kaito, and you can use everything that we just showed here
Sweet.
in production for any workload, any application that you have, all the models in there. You can use them to automate all your workflow. You have all the optimization and tuning that you saw here,
Nice.
and have additional integrations that we're continuously building, not just the VS Code integration, but more with monitoring and other services in Azure that we're going to show in a bit.
Okay.
Not just in AKS, and Satya kind of pre-announced some of this in the keynote. I'm still upset
So your
about.
thunder, huh?
You're also able to use this in Arc as well. So if you have Kubernetes clusters at the edge, you can now run all of this in the power of the cloud in terms of GPU. And now you can install Arc, which is not install Kaito, which is now in public preview in Arc Kubernetes clusters, and run, for example, the inferencing server there close to your edge. So you can do tuning in the cloud and then run the inferencing in your edge hardware, for example, or run everything in your edge hardware, up to you.
Yeah.
So pretty exciting to bring all of these capabilities to this continuance between cloud and hybrid that we have. But Paul, I have a question for you.
Yeah.
Was fine-tuning really the best use case for what we did in terms of providing?
It's almost like the age-old question right now, like
Yes.
fine-tune versus RAG.
Right.
I mean,
For
it
the
could be
scenario-
a toss-up.
For this, it could be a toss-up. Again, fine-tuning is really good for fine-tuning and the context about your data.
Yeah.
But really, what we had there is more of a RAG scenario. That's
I
what
would say so.
What we did in terms of a PR reviewer would benefit a lot more from retrieval augmented generation, which is what RAG stands for, and actually give them things like more repos, all the PRs that we had across the board. And so we're also happy to announce that already in the open source project, because Kaito is part of the CNCF and is a full open source project, you already have RAG available to you. And this will be coming into AKS, the fully managed add-on, on the subsequent release of Kaito as well. So you'll be able to do not only fine-tune, but also retrieval augmented generation as well moving forward, making it all your inferencing scenarios, dreams come true.
I feel like I need to update the PR agent now.
Indeed, and that would be making it run on steroids really well, in terms
Okay.
of what it could do.
All right.
Does this finish our AI loop? And the answer is not yet. It does finish kind of our top line over there. We've started, we've experimented with models, we gave it some grounding and context, We will improve even more with RAG. We've automated pipelines to do continuous tuning. We have all the webhooks created. We have the apps on GitHub. Pretty cool. What's next? And as we start to go back into the lower kind of row there, it would be nice to kind of monitor the performance and continuously improve there.
You know, I think monitoring is a good thing.
What can you tell us about AI observability?
Yeah. So the thing about observability is like with Kubernetes, with microservices, I mean, we just have to observe all the things, right? We have to observe hardware performance, the application performance, but now we also have to worry about model performance, right? And so we need to incorporate additional monitoring capabilities on top of what we already have. And so this is why I think the defaulting to the vLLM server is so cool, because by default, you'll have the ability to automatically take advantage of the /metrics endpoint, which is enabled by the Kaito team, by the way. And these are all Prometheus-based metrics, which you can then scrape into your Azure Managed Prometheus service. So scraping the data is one thing. You would want to visualize it, right? And so what you could do is you can actually hop on over to the Azure Managed Grafana instance, which is connected to your AKS cluster, and you can start to build these nice elaborate dashboards. Well, I've
never built a dashboard in my life.
I'm not good at dashboards. And so you can actually just jump over to the vLLM website, and you can actually take a look at their example Grafana JSON and use that as a starting point, as a launch point to build these nice, beautiful dashboards, right? And so what you're going to get here is dashboard. You input your model name, and with a little bit of information kind of like flowing through your model, you can take a look at things like token throughput, cache utilization, things like that. And this can help you further fine tune, like, is my model actually working the way I expect it to?
Right, so based on the usage that you have of it and that your users might have of it, you can now start to monitor and see, is the performance good enough?
Yeah.
Is my GPUs actually the best GPU for it? Is Sky doing a good job? Does the model need more data, better data to give better responses?
Yeah.
Use less tokens, very good.
Yep. And you talked about GPU, like is my GPU working the way I need it to, right? And so the other cool thing about of these observability features is like, we have to monitor these GPUs now. Yeah. And so AKS actually supports the DCGM exporter for your NVIDIA-based GPUs. And so you can actually go out to the docs and you can see how you can actually install that exporter into your AKS cluster. And man, that's a really nice dashboard.
Yeah. This is exactly what I was mentioning before when I was talking about scaling with Kata. This is the type of data that you can use to do all kinds of things. Tune your workload, look at the performance of your models, but also even scale and do all kinds of things. You can see you have the actual utilization there coming straight from the GPU and a lot more.
Yeah.
Now, I will say this. I don't love the Grafana dashboard. I don't love that I have to switch between the Azure portal and Grafana.
You don't love the fact of switching. It's not that you don't like the dashboard.
Oh, I love Grafana, yes. I just don't like the switching.
Yeah. Yeah. So with that, inside of the AKS portal now, Grafana dashboards are made available. And I could just show you a quick picture of it because, you know.
We're doing live demos?
I mean,
we promised we wouldn't do live demos.
It's not 100% live, but this is my live Azure portal. And you can see here, wait, there we go. Okay, here we go. So you can see that I am actually in the AKS portal. And if you scroll all the way down to the monitoring section, you might have seen that there is the dashboards with Grafana option now. And so you can actually click on that and do the same process that I did over in the Grafana dashboard, import the JSON, and now you don't have to context switch between Azure Managed Grafana or Azure Portal. You can just stay all within the Azure Portal and see the same exact metrics and get that beautiful.
Yeah, so you don't lose any of the flexibility that you had before. You can still import dashboards as much as you want, but now you don't need to leave Portal. So you don't lose any of that flexibility that you had. And if you love the Grafana Portal and the switch, still do it.
Yeah.
I prefer to stay really close to all my resources and all my apps and doing more. All right. So, are we done? And the answer is not yet, right? There was a last point on that loop, which was what about day 2 operations? As in, I now have my app deployed, I have my model deployed, I have my monitoring, my perf is fine, so I'm done. And as Kobe says, job's not done.
Job's never done.
But we do want to make sure that you actually don't have day 2 operations to do. As part of AKS's main set of functionality, our goal is for every time that you get to day 2, that the answer is there's pretty much nothing more for you to do. We got the question recently as well throughout the event of just like, hey, what's your recommendation for when I should upgrade or when I should tell my teams to upgrade and do things? And we were answering, it's like, well, hopefully you don't need to do anything for that. You just turn on auto upgrade, set your maintenance window, put your environments in a fleet, and go to sleep.
Go to sleep. I like that.
And sleep nice and sound. Don't have to wake up. Don't even have to call the SRE agent that we just announced for anything because the operation itself is taking care of the upgrade, making sure that nothing crashes across the board, etc. So managed operations is our key point. Developer productivity is the other, which is how do we, not in a simple scenario like what Paul did with that chat agent, but also not just leveraging an open source existing solution. When we're developing something from scratch, how do we get that developer productivity to go quickly? One of the things that Paul shared was in our PR sample, PR agent sample in the Kaito repo that is available for everyone, by the way, we added the Kubernetes manifest to deploy this, to deploy that agent to Kubernetes. But what if you're creating your own agent? What if you're deploying an existing agent that is not containerized, like it was the case with Kodo, where you could leverage things that we just showed in the previous session over at that room, which was you could leverage Draft to actually generate the deployments and the service, which is what we did. And then you can leverage Copilot to iterate through your config map to get that configuration, look at the Kodo instructions and say, oh, I need that configuration, that TOML file to be loaded somewhere. Oh, that's a config map. And Copilot will help you add that last piece, which is something that we demoed on the last session as well. So take a look at that one if you're interested. But it goes beyond that, how you run that across the world. With Fleet, you can point those workloads into a Fleet hub, and then that can deploy across the world for capacity, for availability, for quota. So you can have not just the region where you are as your cloud, but actually the 60+ regions that Azure has as your cloud. And do so without having to be concerned about maintaining a bunch of different environments and more. You can simply point that to a Fleet and send it to the region where maybe you have the cheapest GPU or you have the most available GPU and more. You have the elastic scalability and cost savings that Kubernetes gives you and the integrations that we have with Kata, with auto-provision, with autoscaler gives you. We have automatic patching and upgrades. You have all the observability that you started to show, but it goes beyond, of course, the models and all the way to your applications.
Right.
That was just a model and GPU dashboard. The built-in dashboards we have for applications and infra are even more rich across the board. We have all the security controls for all compliance. Like I still am with out there. I think I launched that at Ignite 3 years ago. The challenge of if you have a compliance standard that we're not meeting, I will buy you dinner.
Hey!
And you can prove it. I will buy you dinner personally, and then I'll go in and add that compliance standard back. But as far as we know, we're meeting every compliance standard for every industry out there. We have customers far and wide, 96% of all Fortune 500 using mission critical applications and workloads in AKS across the board.
Nice.
And then we leverage, like we said on the case for open source models, you have all the breadth and depth of open source to your disposal, not just for models, but across any tool out there.
The entire ecosystem.
Anything that you might want, from databases to tools to observability. If you're not happy with some of the things that we built, and you're very happy and more comfortable and prefer something else, you can just run it on AKS as well. Together with this, we've had a few releases and a few things that contribute quite a lot for our, let's say, more AI workloads and AI agents running on a Kubernetes cluster. You have things like artifact streaming that increase the performance and decrease the latency of image pools and new containers running cold, meaning that there's nothing cached in the node, from many minutes for large images to just a few seconds. We have cases of things taking 8 minutes, moving on to 6 seconds across the board. This is available today for you to test out. And it's a great partnership we have between AKS and ACR, where you have a different format for your image that is much more efficient and also has and uses the concept of lazy pooling that will start your container as it's still pulling several layers from it. So imagine things like a Java application, very common, one of the most popular languages still in AKS and I think in the world.
Yeah.
And your JVM will take some time to start, and then your application's loaded and all that. But that's a perfect case where artifact streaming is incredible because it will kick off the JVM start while it's still pulling the rest of the application.
That's nice.
Really, really, really nice. The same concept as you have like, I don't know, Netflix and more, where you start to see before everything is downloaded, of course, or video games and more.
Because we don't like waiting.
Yes, who likes waiting? And this improves the scalability and the latency across your whole end-to-end operation by a lot. You have deployment safeguards that allow you to essentially gift namespaces to developers and have the cluster with guardrails for all of them that enforces essentially Kubernetes best practices. So you don't have to be doing and crafting policies on your own. This leverages Azure Policy and the Azure Policy integration that is already there in AKS, but you can now leverage it on your own. We've also GA'd network isolated cluster because a lot of these clusters, you're running models there. You're having data of your own in the cluster. So you often have incredible concerns about data exfiltration in these cases. With network isolated, you can have a cluster with no access to the internet, where before we required that you had give us access to the endpoints that we use to manage the cluster. Those are things like MCR, the Microsoft Container Registry, where we pull the images for the add-ons and more. And so we needed to have connection for that.
Yeah.
Packages.microsoft.com, essentially the places where we had our stuff. With network isolated, you can pass on a bootstrap ACR. So it's an integration with ACR that itself is going through our backbone, bring everything down from MCR, and you can private link that ACR to your subnet of your cluster. And from there, everything is private. So what this entails is your cluster can be booted up, bootstrapped, with no egress connections at all, even to our own endpoints as we did before. So for these cases where, of course, you're going to have concerns of data exfiltration, that's the reason why maybe you're not using a SaaS in the first place.
Yeah.
You can be sure that we have those controls available for you. What about security in terms of patching? Well, we have, at this point, all kinds of patching channels that you can leverage. From node image, that is a weekly new image that you can leverage for your nodes, to the Kubernetes patch published essentially as they get dropped upstream, and you have access to all of them, to our OS security patching channel that brings every fix that you have out there tested in 5 days or less to your Kubernetes cluster if it's an OS fix. So that if you have, again, any of those compliance standards that require very aggressive time to patch, you get those patches really, really quickly. We have things like max and available. What is max and available? It's the ability to upgrade without using our typical mechanism of surging. AKS usually, when you upgrade, will surge a node for you, which is like a buffer node, where then the pods get moved to and from as you're running your upgrade. Now, if you're in these cases that we just showed, you're in a GPU scenario, you might not want to spun up a full GPU. Maybe you might even be not making a lot of use of it, and there's space in it at the point that you upgrade because you're upgrading in a maintenance window, for example. You might not have quota because it's pretty scarce to get that quota for you. And so max and available allows you to upgrade with the existing capacity in the cluster, so you don't need to surge a buffer node. You can also fall back into it. Maybe you do have that, but for some reason you can't get that new node. You can try with surge and fall back into max and available if you need. You can use the cluster optimization workbooks that were demonstrated on one of our cost optimization sessions earlier today in the morning, where you can leverage, is my cluster being used the most? Is it being efficiently used, effectively used, or not? We have GA'd the Microsoft Copilot for Azure, which if you haven't tried out for essentially every of your tasks, it really helps. It's now AI for AI in his case, which is you can leverage the Microsoft Copilot for Azure to ask things like, hey, where can I get a Grafana dashboard to monitor my GPUs, to run my agents, to provide my AI solutions? And so this is the nice vicious cycle that we definitely want. We want Copilot and things like the SRE agent to help you with everything that you might need, from troubleshooting to any operation that are still left there. And finally, we're now previewing the Defender for Cloud gating capability. Very, very important, because everything I talked about in terms of patching is our stuff. But again, this is your data. These are environments where you're so concerned that you want to make sure it's isolated. How do you make sure that even your application, maybe you have multiple teams, are not just sliding into the cluster with vulnerabilities, where gating stops that? You can configure Defender for Cloud gating to stop any deployments that contain vulnerabilities into the cluster. This is both malicious, but also just inadvertent, which is honestly 99% of the cases where just your developers are just shipping the same image as before that has now 10 new vulnerabilities over and over. And this is hopefully a finishing of the loop of why we see, and we hope that you see as well, why AKS is the platform, together with Kubernetes, of course, for your AI workloads, and how we helped across the board, the top line and the bottom line as well. We'd like to stop being your last line, your last barrier.
I think there's a party tonight, right?
From the party, and cut it fairly short. We had great sessions today and yesterday. Definitely recommend you checking the recordings there. Mm-hmm. We have a lot of AKS resources that I'll let here for any picture, but you also can get access to the slides. So we have, our releases are all public. You can track them across regions, including for the Kaito GA that is upcoming on the next release. You can check our public roadmap, ask us any questions and feedback in our feedback link, which is GitHub as well. We should definitely take a look at our blog, Kaito fine-tuning, InfiniBand support.
Yep.
A lot of those things are hitting the blog very early, because we want to share a lot of the work we're doing in the open source space with you a lot. And then obviously landing in our docs as they become part of the product. We run monthly community calls in case you want to share feedback, ask questions, bring your friends and family. We're happy to host you in our community calls. And as I mentioned at the early part of the session, we have our YouTube channel, our community.
That's correct.
Where all our events and all sessions that we do across the world, KubeCon, Paul has several sessions that he's done on Kaito already uploaded. And we have also a bunch of labs happening live in the Reactor.
Yes.
That's right?
Yeah.
Talk about that?
Yep, that's correct. So basically, a lot of the content that we do, we put them all in lab form so that you can all do it at home. But a lot of times you would want some sort of instructor along the way. And so on the Microsoft Reactor channel, between now and the end of August, we will be running a lab every other week. And so we invite you to join in, scan that QR code, register, and it's like every other Tuesday at 8 a.m. Pacific. So yeah, hope to see you.
Are you the instructor?
I am the instructor for a few, and it sounds like on the one on August 19th, there might be some new Kaito goodies in there.
Oh, interesting.
Maybe.
There goes the mic.
There goes the mic. It's time to go.
All right. So before we finish, a simple question, I hope.
What's that?
That is worth one of the Kubernetes best practices.
Wait.
That Brendan Burns, I think, autographed, I believe.
That's the one that he wrote?
Yes, that's the one that he wrote.
Yeah.
And autographed.
Hey.
That is going to be a gift for the first person to answer the question. You want to make the question?
Ask the question.
All right. What's the runtime that Kaito ships by default?
The inference runtime.
The inference runtime. Well, who's first? All right, very good. VLLM, very good. I'll give you the book to yourself afterwards. Yeah. All right, and with that, thank you everyone. I hope you enjoyed the celebration. I hope the session was helpful for you and you enjoy Build. We have a few minutes still before it's officially over and got kicked out by these fine gentlemen. So feel free to come up and ask any questions you might have. Enjoy the rest of the conference.
Thank you.